name is Dima Tawaz. I'm a mechanical engineer, and I'm one of the engineers who worked on the solar panel design.
My name is Samir Nirgard. I'm one of the engineers who designed the solar panel project.
I'm Jemi Demiroğlu. I'm a principal design mechanical engineer on the Sunflower team.
So the name of the project is the Sunflower. The reason we called it that is because flowers harness energy from the sun, and sunflowers harness energy a bit better by tracking the sun's movement and moving with it.
Essentially, it comes from mimicking biology and the environment around us. It's a concept called biomimicking. So we're mimicking something from the outer world, and a flower acts similar to the solar panel.
So it has some technology called photocells. These are used in your phone to basically change the illumination of your phone screen based off of how much light is sent on top of it. Now this is a very cheap technology and very simple that we can apply to solar panel technology. So we have 4 on either end. It senses the top, left, bottom, right, and moves the motors based off of that. Now on top of that, we also have a cleaner.
Essentially, we have 2 servo motors that are in sync, attached to a cylindrical cleaning device, and it rolls across the surface of the solar panel to clean any debris and dirt that might have accumulated on the panel.
Everyone could use it for any sort of application, to charge your phones, to when you're hiking out in the woods where there's no power source or outlet to charge your phone. So this comes in very handy for a lot of different applications.
If these solar panels are made in a larger scale, they can be placed on top of rooftops and used to power larger scale electronic devices in households, such as refrigerators, TVs and stuff, with clean renewable energy.
To me, this is something interesting because I come from Saudi Arabia, and part of the vision for 2030 is to move away from petroleum as an energy source and to move into something that's more reliable and more efficient. Instead of wasting the sunlight, we're kind of converting that energy into something more useful to power devices and any small electronic device, basically.
So as engineers, we want to make this as simple as possible to put together. So we have a bunch of snap fits. These are basically things that you can just place together, and by force, they click together. We have it in 3 parts: the base with the motor, and the cleaner with the roller.
Currently, we're still in the prototyping stage. It displays all the functions that it has to. It can track the sunlight perfectly, it can generate power, and it can clean itself with the cleaning mechanism. However, the design is a little clunky, and we can definitely make improvements by using smaller motors and sleeker design to make it more user-friendly.
And what we want to get is a bit of more funding to basically clean it up, make sure that we can get an efficient source of battery to recycle the power that's taken from the sun to the motors.